Hi, in this video I will summarize some of my learnings after reading Chapter 7 of Clean Code, which is all about doing effective error handling in your application code. Here's a quick overview of exception hierarchy in Java. So there are two types of throwable issues in Java. One is error codes that are throwable and exceptions that are throwable. Errors are typically situations which are not recoverable, which should not be caught by the developer. Things like linkage, class linkage errors, annotation, parse errors, virtual memory errors, etc. These are system errors that need to be addressed in a systematic way that the developer, application developer, shouldn't have to worry about in their application code. There's definitely things that they'd have to do to address these errors, but they should not have to worry about in their application codes. Exceptions, on the other hand, are two types: checked and unchecked exceptions. Checked exceptions are exceptions that the developer in their library or the API expects you to catch, expects you to declare those exceptions in the method signatures, expects you to recover all of those issues or errors that happen. And those are very important set of exceptions that need to be caught. Everything else is unchecked exceptions or runtime exceptions that are caused by the developer that they need to look at. Things like null pointer exceptions, timeout exceptions, file not found exception. They should be caught. These runtime exceptions should be caught. They could be declared and they are recoverable errors. So that's the exception hierarchy. Errors and exception. These are issues that can happen in your code, and this is the hierarchy. In this chapter, the author talks about how do you handle exceptions or issues that the developer can take care of. And the exceptions could be handled using exceptions. Issues could be handled using exceptions, which is checked and unchecked runtime exceptions. Whereas it can also be handled using error codes. In exceptions, you get the benefit of the full stack trace. You get the benefit of putting in the intent in your logs, etc. In error codes, if you're not doing it well, then if the caller of your code does not catch those errors or does not handle those errors well, then they may just omit doing the right thing. So it's pretty easy to omit handling all error codes. Maintaining all error codes is hard. Whereas in exceptions, you have the benefit of stopping the program and causing issues that are evident to be fixed, right? Also, with exceptions, the code looks cleaner. The business logic, the algorithm, the normal flow of your code is much more separated than the exception handling code if you write them well. Whereas in error codes, your logic of your code, your main algorithm, is filled all over the place with error handling. So testing is harder. But the pro is that for critical libraries or for critical software that has to work, like airline software or something like that, then maybe error codes might be a great idea when you have to handle all kinds of situations, all kinds of errors need to be handled. And these are not errors, the Java errors that we talked about in the previous slide. These are exceptions that are either, when I mean errors here, I mean errors that are runtime errors or checked exceptions here. So for critical library code, maybe error codes with all kinds of error handling is the way to go. But for application codes, exception seems like a better way to go. I read a lot of blogs. The author has a clear perspective of using exceptions over error codes, but it can be debated. It can be debated on what's the right thing to do. But as a general rule of thumb, exceptions seems like a better use case for application developers to have less cluttered of a code, handle issues, better testable code. So that's one of the major topics in this chapter, using exceptions over error codes as much as possible. I've added some links in the reference section where there are a lot of interesting blogs from Microsoft and from the CEO of Stack Overflow who have different perspectives on what should be the right preference. The other topic is around nulls. Do not return nulls. Use special case object patterns, null object patterns instead. Otherwise, what happens if you, in most object-oriented languages, such as Java and C#, references may be null. These references need to be checked to ensure that they are not null before invoking any methods. And so what happens is if you return null or if you pass in null, then there is null checks everywhere. Special object patterns could be used as given in this example by Roger in his blog post. What you do is you create an immutable singleton or null objects which replace the null reference, and it provides you for a unique way in which you handle nulls. This avoids null checks everywhere in your code, also enables you to centralize null checks here, provide unique implementations on how null objects are treated and created and how you monitor them. Using this pattern sparingly is advised because there could be careless mistakes. Programs may run and everything appears to be running fine in the execution, but things may not be running well. So typically do not return nulls. Create wrapper APIs for exception handling and null case handling so that testing's easier, library migration's easier, mocking's easier, code looks much more cleaner instead of passing in nulls and returning nulls. So these are some of the references from Microsoft and some of the blog posts, and credit goes to the author, Robert Martin. Highly recommend this book. Thanks.